look, it's Roger Wakefield. So, I was reading the September edition of PHC News when I came across an article written by Stephen Minnick about flame rectification. Stephen is a very knowledgeable tradesman with many years of experience. This article is especially interesting because if there was one thing I love more than fire or electricity, it is fire with electricity. In case you don't know what flame rectification is, let me tell you why it's important. In this example, we're going to pretend that there's no such thing as flame rectification. Let's say your thermostat had a call for heat. Now the gas valve comes on, but the pilot did not light. 30 minutes go by. Then the gas finds an ignition source like a spark. Flame rectification stops this from happening. So here's the deal. The flame conducts electricity. Think of the flame as a bridge. Pretend electrons are little people. And for some reason, we have more electrons crossing the bridge in one direction than we do the other. This is called DC bias. But I want to know why this happens. In the article, Stephen states that the magic of DC bias and flame rectification is achieved by one electrode being at least 4 times larger than the other. My refrigeration and air conditioning technology textbook also states that the DC bias is caused by the electrodes being different sizes. I found this lecture on YouTube, and he also says the same thing. Alright guys, time to say my experiment. As you can see, I have hot, neutral, and my meter tied in series, and 2 electrodes. Now what I want you to know is that my electrodes are the exact same size.
So you got a very small flame probe, a very large ground, and because of the dissimilar mass, what will happen is that the current can flow very readily in one direction, but it is impeded based upon the size of the ground in going the second direction, or the negative side.
Okay, we're going hot. Okay, on our meter, we're going to select microamps DC. To simulate a pilot flame, I'm going to use a torch. Can you believe that? Over 10 microamps of DC bias. And the electrodes are the same size. As you can see from the Wikipedia article on flame rectification, there seems to be some debate as to what the actual mechanism is that causes the DC bias. Okay guys, I need your help. I need you to find an engineer to help me with this. Maybe like the engineering mindset. Did I mention I want to be an engineer when I grow up?